Welcome to the Stormsurf video surf forecast for the week starting Sunday, August 23rd. We're going to move fast tonight because there's a lot to cover and very little time. First off, quick look at the southern hemisphere. Not a whole lot going on, but that is to change quickly. First, we'll take a quick look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, help direct their track. We're looking for troughs, a bend in the southern branch of the jet pushing to the north. So we'll scroll through this real quick, and we see a little trough right here starting on Monday night, mainly a primer trough south of New Zealand, trying to help support gale development down low at the surface. But notice it pretty much turns into a ridge, starts pushing south, doesn't do a whole lot. But then right behind it, another trough is forecast building started Thursday evening, and that covers a larger area and gets more traction with a good amount of winds, 150 knot winds feeding up into it. That should support gale formation. And look at this, by Saturday night, more winds come in to reinforce it. There we go, at about just barely 140 knots, but carving out yet a bigger trough, going the whole and holding while easing east through into Monday and looking to go even beyond that. Of course, over to the west, the ridge starts again, but at least based on the upper level model, it looks like there is good support for gale development down at lower levels of the atmosphere. Let's go find out. So here we are, down at the surface level pressure, high pressure, east of New Zealand, 1028 millibars, ridging south, not horribly so, to about 58 south. And then this sort of cut-off low pressure type thing going on between the two tracks in the jet stream. But this isn't really what interests us. We want to see, and there we go, just as we thought, a upper level trough we saw south of New Zealand on Monday night, and sure enough, a gale starts developing, 45 knot winds, doesn't last long at all, and then quickly collapses with another semi kind of trough looking thing pushing through on Wednesday, developing with 45 knot winds, and then building from there into Thursday. What is that? 55 knot winds over a small area, aimed pretty well to the north, and then reinforcing energy coming behind that, building, there we go, well, back there, 50 knot winds, a good solid pocket of 50 knot winds on Friday, and again, aimed mainly east, but a bit to the northeast, and continuing on, just steady flow of fetch in this area. We're into Sunday now, and yet more. Look at this, 35 knot winds. So clearly there is some gale activity forecast for this area. It looks like the big ridge of high pressure that has been locking down the upper atmosphere is finally set to break. Let's see what effect these winds have on the ocean surface. So here we are, southern hemisphere, not a whole lot going on as we saw before. We'll roll this out into motion. Sure enough, little gale tries to develop southwest of Tasmania. This is on Monday, but that wasn't, it's when it moves here more towards south of New Zealand. We get some, what is that, 32, 33 foot seas, and that is in the southern, or northern California swell window, about 219 degrees, and same thing for southern California. 218, 219 degrees. But relative to Hawaii, shadowed. Look at that. The boot of New Zealand totally blocking any swell energy from working its way to Hawaii. Anyway, that system moves east, fades, and then another one develops this on Wednesday relative to Northern California on about the 211 degree track, and that is right on the hairy edge of the shadow relative to Tahiti, and in the shadow on the 212 degree track for Southern California. Anyway, that moves east, sort of fades out. Another one develops, just as we saw on Thursday night, this with 40-foot seas, again about the 208 degree track relative to Northern California, and a little bit different for Southern California. What is that, about the 204 or 5, and again that is shadowed as well, and then gets reinforced and builds nicely by Friday. Let's see where that goes. Right there, that's about the peak of it, about 42-foot seas, and again relative to Northern California on the, what is it, about the 204, just starting to work its way out of the shadow, and the about the 203, 4, something like that for Southern California and unshadowed. And of course in the Hawaii swell window, that's about the 187, aimed pretty well across the Great Circle Paths, not pushing up, but certainly Hawaii should get some energy from that. And look at this, then it sort of builds pushes a little bit better to the north, and we're not going to, drive into all the details here, but aimed well up the Great Circle paths to California, and again, sort of that cross-cut issue relative to Hawaii, and then starts easing east and fading out into, and there we go, and that's 180 hours. But still, if this were to come to pass, solid swell, 17, 18 second or better swell, could reach into California, sideband energy for Hawaii, and certainly if we go back and just do a quick glance here relative to Cabo San Lucas, for sure, look at that, aimed right up the paths there. Costa Rica, of course, almost a little bit north of the paths in Costa Rica, and Peru, again, a little bit north, but certainly swell for this whole region, absolutely. Let's move on. And here we are. In the northern hemisphere, we're going right to the surface level charts. Typhoon Atsani, southeast of Japan. All eyes have been on the system. It was doing one of these things, did the recurve, and is now starting to move to the northeast. This is a significant development considering that is still at hurricane strength. It is recurving to the northeast, and it is still the later part of August, but that is a good sign. So we'll just run right through this. Look at how this system goes. Good solid winds. Per the GFS model, it's actually supposed to rebuild and get some solid winds pushing here in the southeast quadrant, which is up to the northeast, and I'll show you why that's important in a minute. But anyway, so it's really, if you watch it closely here, starting about, we'll go Monday morning, Monday night, things start looking good. Tuesday morning, and then it starts falling apart on Tuesday night. And notice, big blocking ridge of high pressure here. So this system will not make any further headway into the Gulf of Alaska. Unfortunately, it would be great if this system could have come right in here, but we have high pressure. The good news about high pressure being here, it keeps storms away. You don't have any weather. It also keeps winds relatively light in the California swell window and also for Hawaii. Anyway, this guy percolates out here, the remnants of Atsani into Thursday. Also notice Kilo here, forecast to redevelop. Per this model, not having any effect on Hawaii. And then there was another system, if you notice it here, if you look real closely, it's supposed to develop, suck north too, but not really do a whole lot. And then also notice this, on Friday night, another gale develops first of the season in the northern Gulf of Alaska, theoretically falling south, 30 to 35 knot winds. This in the swell window relative to northern California, pretty much northerly, like 315 for Northern California, not so much for Southern California, but for, we'll say, Central California northward. And this actually is a better run than it was this morning. 35 knot winds holding pretty good. Also notice a front here almost making it into Northern California. Wouldn't be surprised to see a little rain, certainly through Oregon, if this does what it's supposed to do. And then Kilo develops more. Tracking east. That's all we have. And another system forecast out here. Never believe anything a week out on the GFS. Certainly not tropical systems. But this gives you a sense of what's going on. Let's dive into some details here. Here's the official track of Atsani. There's Japan. Here's where we are. Atsani is right now. Wind 75 knots. Per this, and definitely going off to the northeast. Per this, if you look, winds are supposed to die down below hurricane force by, what is that? Per this, about Tuesday into Wednesday, which is somewhat consistent with the GFS. So the GFS actually shows winds building, not doing this steady fade before the system fades out. So that's a little bit of a head scratcher here, wondering which way is really going to how this is actually going to play out. But let's go see the effect of these winds on the ocean surface. So here we go. Significant wave heights as of 18C Sunday. 39 feet per this, where the hurricane model shows only 24 foot. So again, we got to try to sort through that. But assuming this to be correct, we'll just roll this out. We'll go into Monday morning, 46 foot seas. Monday night, 51 foot seas. Tuesday morning, 60 foot seas. Notice the arrows here, and we're going to get into that in a minute. And winds also at 78 knots. Tuesday night, then fading down to 44 feet with winds down to 58 knots, and then it all pretty much fades from there. But we'll roll this out anyway. See, this other tropical system that develops gets sucked into this, but really doesn't do a whole lot. And then also notice the gale in the Gulf, 20-foot seas Friday night, falling southeast and continuing. Again, this is better. This is multiple readings of 20-foot seas. Now, that's, in terms of winter standard, it's nothing, but that's good for 13-second period swell at exposed breaks in central and northern California. So that's something to watch, especially considering that it is just August now, and we're already looking at swell from Etsani and maybe one from the north. Again, these are the sort of things that we look for in August to give us indications of how strong El Niño's coupling to the atmosphere is. And based on what we're seeing right now, things look pretty well coupled at just a purely practical standpoint. And then, of course, we have Kilo, now forecast to build, and how much you want to bet it does the recurve thing too. If we were in a good, strong El Niño situation, that's exactly what we'd expect. But again, never believe any model a week out in regards to tropical systems. Now, one last look here at something else. So now we're going back almost a week ago. Here's Etsani. Here's another system called Gani. Prior, leading the way. It ultimately ended up going into here and is poised to hit southern Japan. Not really a swell maker, but notice it too actually did a turn right about here. Watch this. To the north. Whoops, there it goes. Along with Etsani here. And so where are we? We're right about, there's current time now. So here's what we want to get to. The Great Circle paths for Northern California. And you notice if a storm is going up in this way, it's pushing right up the paths. Relative to Hawaii, not so much. If you have to get more of a flat west-east kind of movement, if you're doing this kind of a track, then you're cutting across the paths. Anyway, so here we'll do this real quick relative to California. And basically, this system is forecast on about the 296-degree track and then fading out. Now let's go back and do this again real quick relative to Hawaii, just so you can see the difference in the track here. It kind of pushes up, but then when it really gets going, it kind of cuts across the paths. So the net result here, and then while we go through this, okay, let's do the one last thing here as well for Northern California. Here's this system here falling down. Now it's cutting across the paths relative to Northern California, but still just proximity and spreading. Some swell will work its way in there. So the point being, we have an Etsani swell that probably will affect both Hawaii and California. The question is, are the wave models right, or is the forecast from the hurricane tracker closer to right? We'll have to go look at some JSON2 data as we get closer to find out. And the odds of getting a good clean pass over the center of a storm are very, very slim. But maybe we'll get lucky and get at least a pass or two close enough to give us a hint of which one is the leading candidate for the truth. The thought is still some small swell, nothing huge, nothing epic, could probably result for both Hawaii and California. And any kind of a extratropical or tropical swell that makes it to these locations in mid to late August. We said this several weeks back. If you can get swell from, in the mid-August time frame, that's a really good sign, and we expect that to probably happen. So given that, let's start digging into what's really going on with El Nino. So first up, sea surface temperature analysis. Here we have the clearly defined El Nino warm pool associated with this year's event. Notice pockets of warm water embedded here, and notice a bit of a breakup of warm water here between Galapagos and Ecuador. This part of a pause in the Kelvin wave eruption cycle, basically an upwelling phase of the Kelvin wave taking place. So we've talked some about this area not looking particularly defined, and that is true. It looks not as defined as it was before, but it covers a good area. And notice there's a lot of warm water moving into the Nino 3.4 region. That is a box if you drew it right about here. This is where what NOAA uses to define the strength of an El Nino. The more warm water that makes it in here, the stronger the El Nino. Now the point being, we had a big eruption of a Kelvin wave here earlier. It looked like this. Notice the concentration of warm waters here. This was in the middle of July. Those warm waters have advected off to the west and are now moving into here, cooling some. Yes, these are anomalies, differences from normal for this time of year, but still warmed considerably. And when we say considerably, we're saying we're practically, as of, if you look at daily values right now, we are practically at super El Nino strength already. In fact, let's show it. So this is what you would call the average temperature, considering all the space in the Nino 3.4 area, roughly from 120 to 170, 5 north, 5 south. And you can see the trend has definitely, since May, has been just this steady upward progression. Right now, and this is just a 2-day spike, doesn't really count for much. Oh, this is, we're up to almost 2.3 degrees now. Okay, but will it hold? Probably not. It's going to collapse at some point, but maybe not horribly. I mean, even if you're normal El Ninos, so the big, the El Nino of 2009, 2010, which is the last time we had an El Nino, peaked out right around in about the 1.8 reading or so. We've well exceeded that. We're not even in the heart of El Nino yet. We're still just getting warmed up. That is, it's really the fall time frame when El Nino starts digging in, doing its thing. So we're just coming out of summer. We're already at strong El Nino strength, bordering on super El Nino, even if it's just for a temporary spike. Still very impressive indeed. But the issue is, of course, now back to the current image, is there's cool water here. At some point in time, it's going to get picked up by the trade, start making its way to the east, and sort of help bring down temperatures in this area. Maybe. But we've got something else going on, too. We'll get into that in a second. But let's do one thing. Let's put this one. So here we were back in July. Very concentrated, but not so much over here. It was really concentrated in this area. That warm water has made its off way to the west here. Deconcentrated a bit, but warmed up the critical Nino 3.4 region, and that's where you get your good, strong coupling with the atmosphere. You start goosing up the jet stream, and of course, we've seen it with Otsani recurving. We see a gale forecast for the Gulf of Alaska, and probably more activity. This is just the very beginning of probably a long string of recurving tropical systems. Anyway, so how does this compare to the epic El Nino? Well, not really, because there's where you are on the 22nd of August during the epic El Nino. Very concentrated and covering a good area. So we're not in 97 territory yet, but we're not doing too bad. If you went and saw data from the 82-83 El Nino, there was hardly anything going on, and that one was the other super El Nino, so it all just got its act together in the fall and went ballistic. We're way, way, way beyond that. Maybe not in 97 territory, but somewhere between the two. Next, we're going to take a look at the high-res imagery for the Nino 1.2 area, and really just the area around the Galapagos. Now, this is not current. This is July 14th, that same time when we saw all that warm water, the peak of the Nino warm spell. That was caused by a major Kelvin wave erupting here in this area and advecting to the west. What's in the Nino 3.4 region is the results of all this warm water moving off to the west. But then what happened is warm temperatures crashed. This is as of 17 August. Basically, things just dried up. By dried up now, let's be clear. No cold water, just not as warm as what it was. And this was sort of a gap between two Kelvin waves. Notice there's still pockets here of warm water here and there. And then here's where we are now. And so let's just go back and forth. This is just over the past 6 days. Notice we see warming starting to show up. Nothing huge, nothing like back here, but definitely better than where we are there. So the sense is that perhaps this new Kelvin wave, the third in the series, the third major one this year, is the strongest of all of them by a mile. And here you can see warm temperatures, again, in the June-July time frame, up to 3 degrees. This is in the Nino 1.2 region between the Galapagos and Ecuador, or including both those. And we can see certainly the crash that took place bottomed out about 4 days ago, let's say the 18th or so of August. And now we start to see the return of warmer water, plus 1.4 degrees, but we were up at 3 degrees in 3 different spikes here, so we have a long ways to go still, but honestly, it will not take much to recoup that, especially when you see what's happening subsurface-wise. We'll get that into a minute, but we want to do one other high-res investigation here. Now, looking at high-res data going east from about, what's that, 95 west out to 160, so almost all of the Nino 3.4 region would be bound by this box and going a little bit off the edge here. But what we're trying to get at is still, see, there's plenty of warm water in this area working its way off to the west. This was a little bit area of concern here, this little break, but that appears to be filling in. So see where we were August 20th, just 3 days ago. Even a larger discontinuity there now, filling in more. So the sense is this warm water working its way here, filling in here, is what is helping to drive the Nino 3.4 index higher. All very good. Now, but remember, there's cooler water back here that is working its way into this region. The thought was that cooler water from the Nino 1.2 area will help drive these temperatures down at some point, maybe. Take a look at this. So here's another way to look at the high-res data, and we're looking right in this area. This is the trend the past 7 days. So basically, what was the temperatures 7 days ago minus what the temperatures are today? And notice hot spot here, 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 and here. Also notice cool spots here associated with that cooler water that was here working its way off this way, but also warm spots starting to show. The suspicion is a new Kelvin wave is maybe starting to erupt. And notice it hits the Galapagos, sort of is warming on either side of the Galapagos, and just barely starting to make some headway along the Ecuador coast here. The question is, will it fully erupt here along Ecuador, or do most of its eruption over along the Galapagos? If it does it out here, the thought is, or at least as this builds, it might just wipe out these cool pockets and then basically cause the Nino 3.4 temperatures to really not take a hit long term at all, and maybe everything will just be fine. The other, notice warm water still building off the U.S. west coast down into Mexico, and then little streams here also coming off of Japan. So a very warm trend still going on over most of the North Pacific. And then finally, the overview of sea surface temperatures. High res here, 5 kilometer. You can see warm water. Again, it's a rather thin strand as compared to the 97 El Nino, which was, had a lot more breadth to it. But any warm temperatures at all, we'll take it. It's really the Nino 3.4 region that makes the biggest impact on the atmosphere. And so that's where we're watching, and that appears to be solidly warm. So let's take a look subsurface and see what's going on. This is the West Pacific. This is the East Pacific here. These are the two TAO buoys strung across the equator. This is only on the equator, 2 degrees north, 2 degrees south, and the sensors on those buoy anchor lines that help us give the subsurface profile. What we're looking at here is this large area of warm water, 29-degree isotherm, going from 155 west to about 130 west, with a pocket of 30 degrees embedded within that. Most impressive, but is not even the absolute temperatures that matter so much. Also notice a bit of a wall here, a bubble. This is the cool spot that we were talking about between Kelvin waves. But it is the differences in normal anomalies for this time of year that is of most interest. And look at this, 6-degree anomalies here, and a good part of the array here is just shut down, so we don't have anything. And this doesn't even go to Ecuador, so it's off over here somewhere. In fact, this goes to, what is that, 95, and Ecuador's over at 80, so you're off here. A good chunk of our data is missing. The point being, 4-degree anomalies extend from 150. That is roughly from right about here. That's Hawaii, the whole way into the Galapagos. Far warmer than normal temperatures. This is your classic Kelvin wave generated by very strong westerly winds that blew late June, all of July, and up to about a week ago of August. That is actual westerly winds and then anomalies that have helped set up this this Kelvin wave that is poised to erupt. We've been waiting for it to erupt. We thought it actually might start a couple of days ago. It hasn't done it. So we're just looking for sort of any signs that it will erupt, and we think we're getting very close now. Yet here's another way to look at the surface. We talked about the warm anomalies at the surface. This is again from the TAO buoy array, but this image also shows you winds. Notice here, easterly winds trades over the entire region That's not what we want to see. We see westerly anomalies and very strong westerly anomalies here in the northern region, but it is really from 170 west to about 140 east. That's where you really get, if you get westerly anomalies in here or westerly winds, that really helps generate Kelvin waves. Anyway, that giant Kelvin wave that's poised to erupt was caused by massive westerly winds in this area. Those winds have sort of backed off over here in the west end of the Kelvin wave generation area, but are still present well south of Hawaii. Anomalies the whole way basically to south of California. So not a bad situation at all. Here's another way to look at subsurface temperatures. This is actually, you look at sea level height anomalies, strip out all the waves, strip out the tides, strip out any wind chop, and using the JSON-2 satellite, you can build a profile, and warm water at depth displaces surface water up just a couple centimeters, but that's enough to give you an idea of what's going on. You can see there is definitely displacement in this whole area. That's because this massive Kelvin wave with 15 centimeter anomalies all in this region right around here is working its way off to the east. Here's that little pool where the upwelling phase is going on currently, but notice the leading edge has passed over the Galapagos now, and that's why we're starting to see warm pockets in this area. It's fairly shallow right by the Galapagos, so as the Kelvin wave starts pushing in here, some of the the bow wave of it erupts on the west side of the Galapagos, some of it comes off the backside, and then eventually, as it works its way east, it'll all impact the coast here and start gurgling both off to the sides and then getting picked by the trades and heading back this way. And one more view. Yeah. This is older data, August 16th, but you see the big Kelvin wave here. 1, 2, 3, 4, 5, 6, and there's one embedded 7. 1, 2, 3, 4, 5, 6, 7. So 6 degrees plus 7 degrees. I wouldn't be surprised if there's some 8-degree anomalies embedded in this. And again, here's that little cool pocket. This one actually shows below normal temperatures. I'm not sure if that's necessarily true. There's no sensors there, so no one knows for sure. But certainly, very much warm water, and look at this, still advecting or falling south from westerly winds, so more warm water building in this Kelvin wave. And then, of course, finally, the upper ocean heat anomaly content. This is the West Pacific, this is the East Pacific. Time goes down here, and you see one Kelvin wave of September last year, another one in the October, November, December time frame. Upwelling phase of the Kelvin wave, big break here, and basically we never really got our El Nino off the starting blocks last year. And then here we go, come right in January, February, westerly anomalies, good solid Kelvin wave. Notice that here, that was really an eye-opener when that pocket of warm anomalies showed up. Another Kelvin wave in the June time frame, July time frame. And here is finally our new Kelvin wave, massive pocket of greater than 2.5 degree anomalies. We know that better to be more in the 6 to 7 degree range. Anyway, and there's our upwelling phase. You could draw the line right here from the upwelling phase. But this guy's poised to erupt momentarily. The Galapagos are right about here. And this is from the 16th, so it's not surprised if the Kelvin wave has actually pushed into the Galapagos now. So much more warm water on the way. This is a very good thing for the Nino 3.4 region, because eventually these warm waters, though they'll erupt in the Nino 1.2 region, will evect off back to the west and backfill those very warm temperatures that we're already seeing in Nino 3.4. And it is those warm temperatures, the longer they stay warm and the broader coverage they have, the more impact on the atmosphere that will set up, the more it will tease the jet stream, strengthen it, and then help to feed storm development in the fall and winter months. So onward, what's going on in regards to warm water displacement? We are looking for westerly anomalies. We're going back in time, the 17th of August. We're looking on the date line. We're looking in the Kelvin wave generation area, roughly from about here to about here, looking for westerly anomalies. Now, this is up at 850 millibars. Notice a little pocket of easterly anomalies. We're just going day by day. Down at the surface, we have seen no sign of easterly anomalies, just basically dead winds kind of west of the date line. Here we go. And still, and westerly anomalies as of the 21st, a large area and strong westerly anomalies. You can see it here in fact, all these frames, a little bit north of the equator and a little bit east of the Kelvin wave generation area proper. But we suspect this is all having some effect. It's still continuing to push some degree of warm water to depth. So the cycle isn't over. The question is, where do we go from here? So here we go. Kelvin wave generation area defined by this box. A very conservative view. You might be able to go actually up to about 5 north and 5 south. But currently here's what's going on per the GFS model. A little bit of southeast winds. Now that doesn't necessarily constitute anomalies. And we see pretty much nothing going on here. And here is westerly anomalies clearly and moving a bit. These are west-southwest anomalies, but close enough. And we'll just roll this out. You can see those start moving north for the most part. But if your line was here at 5, then they're still at 5 north. They're still in the general vicinity. And then we see basically nothing going on here. Light easterly winds in this region. But again, it takes more than that to be an anomaly. And then by the time you get into Friday, we have basically dead winds, a little bit of east winds in the, what are we talking about? Maybe 8 or 10 knots at the most. But for the most part, up in here, no wind at all. And we'll roll this thing out. And then that no wind pattern builds. No winds are effectively westerly anomalies. And that helps warm water, normally pooled up in the West Pacific, to start falling to depth and creating, we assume, yet another Kelvin wave, or at least more feeding of the existing Kelvin wave. And here we are a week out, basically nothing forecast that would be detrimental to the development of a Kelvin wave. Here's another way to view it. This is the pass from July 24th. The West Pacific here, East Pacific here, time going down this way. Kelvin wave generation area, just draw a line right here. Oranges and reds are westerly anomalies, just nonstop. Well, here's where we've been starting about the 18th of August. This is up at 850 millibars. Easterly anomalies took over. All that really means, and notice the line is about right here, so till about 170 east. We had westerly anomalies east of there, which are still in the Kelvin wave generation area. And notice this little patch of easterly anomalies is forecast to be gone in about 2 days. Then westerly anomalies start building, let's say by about the 27th, 28th. And when you're in here, this is basically the Kelvin wave generation area. So, and again, a little bit of weakness suggested maybe by the end of the month, but nothing too strong. Let's look a little bit further out. This chart is a little bit busier, but is the same basic thing. Reds are westerly anomalies, blues easterly anomalies. This here is an inactive, here we go, I'll pull that in. Here's the different waves represented. Kelvin waves, this is atmospheric Kelvin waves, not water Kelvin waves, oceanic. And Rossby waves, the MJO, and the low pass, which is effectively El Nino. So here we go. Here's right where we are. Here's these little easterly anomalies. This is from an inactive pulse of a Rossby wave. But again, that is supposed to be gone. These are 1 week increments, so maybe 4 days out that all but disappears. We go, and then here's the 150 line, and we see westerly anomalies developing a week out, and then things start getting interesting with when you get into this early September time frame, strong westerly anomalies. That's driven by a Rossby wave, and we'll get into the long-term picture now. Now this chart is a little bit opposite. Time goes from the bottom towards the top. The reds are westerly anomalies. You can see various different pulses or westerly wind bursts. And here we go in the early September time frame. A significant westerly wind burst is projected, followed by continued steady westerly anomalies till the end of November. So what's driving all this? Okay, well let's go. Let's first take a look at the MJO. So here we go. The dotted lines are the inactive phase of the MJO. So when you're in the inactive phase of the MJO, you would think you should have no westerly anomalies, but we do. Okay, and here was the big westerly wind burst in the late June, July time frame. And then even though we were in the inactive phase there and here, we still had westerly wind bursts. And notice this, a major push of the MJO is forecast by about late September and going well into November. Now let's add over top Rossby waves. Okay, and you can clearly see Rossby wave, There is a pulse. Here's a projected Rossby wave, stronger, another pulse. So it's this interaction of the Rossby waves with the El Nino base state that enhances the El Nino base state. And then you get into the active phase of the MJO with some Rossby wave interaction there. And basically, okay, and let's do this one other way. The low pass, here we go. We'll just lay that over top. So this is the building strength of El Nino over time, from 1 or 2 contours to 1, 2, 3, 4, 5, 6 contours as we get into November. Now, again, would anyone believe a model that goes 2 or 3 months out? Well, probably not, but at least it gives you a sense of what might be to come. This early September time frame thingy here with the Rossby wave, and we'll just take the MJO out of the mix. There you go. That really makes it stand out a little bit better. And this is probably believable into here. And if we can get this far, that's good. But anyway, the point being, so we've got a major Kelvin wave getting ready to erupt right now. It'll probably erupt through peaking out in early October is our guess. And then start to fade. But if you get another Kelvin wave from strong westerly anomalies somewhere in this time frame, that would be 2.5 to 3 months. So let's say 2.5 to 3 months from, let's say mid-September to October, November. So you're into December or maybe even January and having maybe another Kelvin wave erupting. And then it still takes probably another month once it erupts off of Ecuador to make its way into the Nino 3.4 region. So the point being, temperatures will spike clearly from the Kelvin wave that's about ready to erupt, a month or so from now. So we're talking, August, September-ish, early October time frame, and then possibly another Kelvin wave in the December time frame. At least that's the fantasy that we're living under right now. And so we're looking forward to that to see what really is going to happen. And finally, what is the effect of all this warm water on the atmosphere? It means nothing if the atmosphere is not being changed by the presence of warm water in the Nino 3.4 region. So, Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers represent a good coupling, or at least the active phase of the MJO. And since the MJO is really not present, and the numbers are, as you can see, still negative and have been, here we go, since July, the past month, we've been on a pretty good tear here of minus 30s, minus 30s, minus 30 there. Currently, today's reading, minus 2.6, so pretty much, not a whole lot of happening there. But it's the 30-day running average that sort of smooths out all that noise and gives you a sense, and look at the pattern here. It's just steadily getting stronger. We're at minus 20.93, minus 20.95. That's the lowest it's been in years in the 30-day range. Now, compared to the super El Nino of 97, the daily numbers, we went and did a little digging around today. We saw numbers in the minus 50 range, and one reading did minus 79 at the peak of El Nino in the December time frame, and averages in the 20s at least, and it was probably more than that. Anyway, and the 90-day running average, currently minus 12.77. We would like to see this down in the minus 15 to minus 18 range, and this lower than that. But for right now, we're doing very good. Again, we got to get into the fall. That's when all this stuff really starts simmering deep in the pot and comes to a rolling boil. For being in the August time frame, we are in great shape. Another index, ENSO precipitation index, 2.04 right now. It was up in the minus 2.5 range, that sort of thing. And here you can go. You can take a look at what it was during the 83 El Nino. It peaked at about 2.2. The 97 about 2.85. So even though this number is higher or is lower than what it was, we're still in the ballpark for two super El Ninos, and we're not even in the peak of the season. So this is, again, we've talked about this before. This is about measuring rainfall anomalies in two different regions, just like the Southern Oscillation Index, here and roughly here. The bigger the disparity between, the more the atmosphere is coupled. And finally, the forecast for the Nino 3.4 region per the CFS version 2 model. That's the model we've been looking at, and basically the only model that really runs out with any length of time that's halfway believable. But so it's actually gone up a little bit. Current saying peak or suggesting peak numbers at 2.1 degrees above normal in the November time frame. That was PDF corrected. They sort of try to normalize it, make it more real. The spike here, this is the uncorrected version, 3.1 degree anomalies in the same time frame. That's a little bit on the high side, not believable. Now there's been another significant upgrade. Check this out. The IRI consensus model. This is basically all the models, including NCP's CFS version 2 and a whole bunch of others, all mapped out. And then they try to sort of say, well, where's the midpoint and what's going on here? Here's the interesting part. Of the statistic models here, they are now saying the peak temperature should be right at 2 degrees. Of the dynamic models, this yellow line, you go up here, the temperature is up to 2.5. This is a significant upgrade from the mid-July plume, which was saying 1.5 and 2 degrees. We're up almost half a degree. So what we're seeing is the dynamic models are suggesting a 2.5 degree average temperature or peak temperature. That is in super El Nino territory. And even the conservative statistic models are saying 2 degree anomalies. So either way, we're into a strong El Nino per this, and that is a good sign. So to wrap this up real quick, Typhoon Swell from Atsani looks likely, nothing huge, but certainly fun. It is a good preliminary sign of what's to come from El Nino. Southern Hemi looks like it's waking up. Possible swell being generated over the next 4 or 5 days or so, and maybe a little bit longer, so that will give us something to tide us over. Of course, El Nino is doing very good, and the projections looking very good. The number one story is we're waiting to get confirmation that the new Kelvin wave is starting to erupt. If that's the case, and if it's erupting west, a little bit west of the Galapagos Islands, our suspicions is it will wipe out any dampening of the water temperatures advecting into the Nino 3.4 region, and basically we're just continuing on the wave of warm temperatures building and building, continuing to fuel El Nino and setting us up in a beautiful situation for this coming fall and winter, better than we've had any year except the 97 El Nino, and maybe better than the 82-83 El Nino. So in your lifetime, you get maybe 1 or 2 of these. This year is looking to be one of those. We don't want to start hyping things out of proportion because we still have a ways to go. But as of right now, historically speaking, things are looking very good. So go get yourself some surf. Keep monitoring what's going on. Definitely be training, preparing yourself for this winter. Things are going to be a bit out of the ordinary. You'll need your strength, endurance, breath-holding exercises, do it all. Get your boards ready. Make sure you got your insurance. And we'll do this again next week. Same time, same channel. Thank you.